Hello everyone, welcome to my channel GVS Chem. In this module, let us discuss the enthalpy of neutralization, enthalpy of atomization and bond enthalpy. Please subscribe to my channel, like, share and comment on my videos. Enthalpy of neutralization. Neutralization is the reaction in which an acid and a base react to form a salt and water. So acid plus base gives salt plus water. Salt plus water. Neutralization reactions are always exothermic. Exothermic means they release heat. Release heat. So in neutralization, what will happen? Let us take an example. HCl aqueous plus NaOH aqueous gives NaCl plus H2O. Therefore, if you write the ionic equation H plus Cl minus plus Na plus OH minus gives Na plus and Cl minus plus H2O. Therefore, this is nothing but the common ions Cl and Na, they can be cancelled, whereas H plus and OH minus gives H2O water. That means neutralization reaction we can define in a different way also. A reaction in which H plus ions from acid react with OH minus ions from base to form water. Now, how do we define the enthalpy of neutralization? Enthalpy change accompanying the formation of 1 mole of water by combination of 1 mole of H plus ions furnished by acid and 1 mole of OH minus ions furnished by base in dilute solutions at standard conditions. So here, during the formation of 1 mole of water molecules, whatever be the amount of heat liberated, that is referred as enthalpy of neutralization. Experimentally, it was found that during the formation of 1 mole of water molecules, when a strong acid and strong base react, the amount of heat liberated is 57.1 kilojoule per mole. Therefore, acid, this is strong acid plus strong base gives salt plus water. This is 1 mole. Therefore, delta H neutralization equal to minus 57.1 kilojoule per mole. When a strong acid and strong base react, the enthalpy of neutralization is minus 57.1 kilojoule per mole. Then what about other cases? So here, strong acid plus weak base gives salt plus water. Similarly, weak acid plus strong base. In these two cases, the enthalpy of neutralization is less than minus 57.1 kilojoule per mole. How much less? That depends on the acid and base we take in the reaction. So this is less than 57.1 means it cannot be fixed for all the combinations of acids and bases. In case of weak acid plus weak acid and weak base, we get the delta H. Enthalpy of neutralization is less than minus 57.1 kilojoule per mole. Now let us do a problem. What would be the heat released when 0.5 mole of HCl is neutralized by 0.5 mole of NaOH? An aqueous solution containing 0.5 mole of nitric acid mixed with an aqueous solution containing 0.3 mole of sodium hydroxide, and the third one is 100 centimeter cube of 0.2 mole HCl is mixed with 200 centimeter cube of 0.3 mKOH. Now let us do these problems one after the other. So the first one is HCl plus NaOH gives NaCl plus H2O. So H plus OH minus gives H2O. Here 1 mole 1 mole of hydrogen combines with 1 mole of OH minus gives we get 1 mole of water. Therefore, delta HN, enthalpy of neutralization during the formation of 1 mole of water from strong acid and strong base reaction is minus 57.1 kilojoule per. But here in the problem, how much it is given? 0.5 mole. So here 0.5 mole of H plus combines with 0.5 mole of OH minus. So in case of H plus and OH minus, both the cases 0.5 mole is given. Therefore, 1.5 mole of hydrogen and 0.5 mole of OH gives, we get 0.5 mole of water. So for 1 mole, what is the heat? The neutralization minus 57.1. For 0.5 mole, how much this is? So this is nothing but 0.5 into 57.1. This equal to 535.28. Therefore, the decimal. So here the value is 28.51 kilojoule per mole. In the previous problem, the second sub question is an aqueous solution containing 0.5 mole of nitric acid is mixed with an aqueous solution containing 0.3 mole of NaOH. Then what is the amount of heat liberated? So here the amount of heat liberated, nitric acid plus NaOH gives NaNO3 sodium nitrate plus water. So here nitric acid is strong acid and NaOH is strong base. Therefore, delta H neutralization is equal to minus 57.1 kilojoule per. Now here H plus OH minus gives water. So 1 mole of H plus and 1 mole of OH minus gives we get 1 mole of water. Say nitric acid, how many moles are available? 0.5 mole of H plus and NaOH 0.3 mole of OH minus. Since OH minus is less, 0.3 mole of OH minus ions combined with 0.3 mole of H plus ions only. Therefore, 0.3 mole of H plus 0.3 mole of OH minus gives 0.3 mole of water. 0.3 mole of water. Now, amount of heat liberated is equal to, for 1 mole this is minus 57.1 into, for 3 moles 0.3 moles, how much this is? So in this reaction, the amount of heat liberated is 17.13 kilojoule. Now the last sub question in the previous question is, how much amount of heat liberated when 100 centimeter cube of 0.2 m HCl is mixed with 200 centimeter cube of 0.3 m KOH? Here in this problem, the volume of acid and base are different. Not only that, the strength of the acid and base are also different. Therefore, we have to equalize their volumes and of course, we have to find the number of moles present in them. So here, 100 centimeter cube of HCl has 0.2 m. 1000 how much? Therefore, this is 100 by 1000 into 0.2. This is nothing but 0.02 m HCl. In the same manner, 200 centimeter cube of NaOH has 0.3 m. 1000 centimeter cube how much? Therefore, this is 200 by 1000 into 0.3. Therefore, this is nothing but 0.06 mole. So, H plus OH minus gives H2O. So, for 1 mole it is 57.1. But here, how many moles are present here? This is 0.02 m HCl and 0.06 m HCl. Therefore, this is nothing but 0.0 H plus 0.02 OH minus. Because only 0.02 m H plus is there, concentration same amount of OH minus also combined with the same, therefore we get water formed equal to 0.02 mole. Therefore delta H neutralization equal to 57.1 into 0.02. So this is nothing but 1.142 kilojoule. 1.142 kilojoule. Now let us do another problem. Calculate the amount of heat liberated when 200 centimeter cube of 0.4 m HCl is mixed with 300 centimeter cube of 0.2 m KOH solution. So here 200 centimeter cube of HCl has 0.4 mole of H plus. Then 1000 how much? Here because volumes are different, we have to equate this to 1000. Therefore, this is 200 by 1000 into 0.4. So this is nothing but 0.08 m H plus. Similarly, how much KOH? 300 centimeter cube of KOH has 0.2 m OH minus. Therefore, 1000 centimeter cube how much? Therefore, this is 300 by 1000 into 0.2 is equal to 0.06 m OH. And this strong gas and strong base, they are reacting. Therefore, we get the heat of neutralization for strong gas and strong base is minus 57.1 kilojoule per mole. So H plus OH minus gives H2O. So 1 mole we get 1 mole. But here how many moles? 0.08 plus 0.06. Therefore, since OH minus is less, only 0.06 mole of H plus ion combines. Therefore, amount of water formed is equal to 0.06 mole. Therefore, heat liberated equal to 57.1 into 0.06. So if you multiply 57.1 and 0.06, we get 3426. Decimal should be kept before 3 places. Therefore, this is amount of heat liberated is 3.426 kilojoule. Now let us discuss the bond enthalpy. So during the formation of bond, energy releases, and during the breaking of bond, energy absorbs. Now let us see the bond enthalpy. The energy required to break a particular bond in gaseous state, gaseous molecule, is referred to as bond dissociation enthalpy. So here, to break the bond in diatomic hydrogen molecule, it needs 435.4 kilojoule. 435 kilojoule. Therefore, delta H dash H. This H indicates enthalpy, and this is the hydrogen bond molecule. Therefore, the bond enthalpy of hydrogen is 435.4 kilojoule. Now let us see the polyatomic molecule. Polyatomic molecule. Polyatomic molecule means having more than 2 atoms. Polyatomic molecule with same type of bond. Same type of bond. For example, water. What is the water? Water has bonds in this manner. So there are 2 number of OH bonds. OH bonds 2 are there. Now how much amount do they take? Let us see. Therefore, this is one side we can take OH dash H. So to break this bond, gas gives H gas plus OH gas. So here bond enthalpy is delta H is equal to 498 kilojoule. Now to break the other bond, O dash H gas gives H gas plus O gas. Here the bond enthalpy delta H is equal to 430 kilojoule. Here both the energies are not same because when first OH bond is broken, then the second one becomes weaker. Therefore, for this this much amount, the more amount of energy is not necessary. Therefore, average bond enthalpy is equal to 498 plus 430 by 2. So this we get 464 kilojoule per mole. So in polyatomic molecules, that is having more than 2 atoms with similar bonds, the bond energy is not same for every bond. The different bond energies are there. Therefore, the mean bond enthalpy or average bond enthalpy can be obtained by taking the average. Thus, the mean bond enthalpy is defined as average amount of energy required to break 1 mole of bonds in that type of gaseous molecule. So the mean bond enthalpy is defined as the average amount of energy required to break 1 mole of bonds of that type in gaseous molecules. Now based on this, let us see an example. Now let us try to understand the bond dissociation enthalpy or mean bond enthalpy. Now let us take an example. CH4 gas, we get C gas plus 4H gas. Delta H equal to how much? That means delta H for CH bond. So this we can find directly from enthalpies of formations of these substances by using Hess law. Therefore, delta H formation for hydrogen equal to 218 kilojoule, carbon equal to 717 kilojoule, and that of methane gas is equal to, this is 75 kilojoule. Therefore, delta RH equal to sigma delta FH products minus sigma delta FH reactants. So in this, what are the products? Equal to, products are carbon and hydrogen. Therefore, delta FH of carbon plus 4 into delta FH of hydrogen minus delta FH of methane. Therefore, substitute the values of enthalpies of formation. For carbon it is 717.0 plus 4 into hydrogen 218.0 minus enthalpy of formation for methane is 75.0. So this is 717 plus, this is 872 minus 75. So if we simplify, we get 1664 kilojoule. So this is for 4 bonds. How many bonds here? C dash H bonds, 4 are there. 4 are there in methane. Therefore, delta H for CH bond equal to 1664 by 4. This is 416 kilojoule per mole. Enthalpy of atomization. Enthalpy of atomization is defined as the enthalpy change accompanying the dissociation of 1 mole of the substance completely into its ions in gaseous state. Now let us take an example for this enthalpy of atomization. Enthalpy of atomization of hydrogen. H2 gas, it dissociates into ions, H ions. Therefore, delta HA Delta H means enthalpy of atomization is equal to 435.4 kilojoule per mole. So this is the enthalpy of atomization of hydrogen. And the enthalpy of atomization of sodium in solid state becomes sodium in gaseous. That means solid sodium atoms are separated from each other. Therefore, enthalpy of atomization of sodium is 108.4 kilojoule per mole. In case of methane, enthalpy of atomization CH4 methane. So CH4 in gaseous state becomes C in gas and 4 hydrogens in gas. So enthalpy of atomization of methane is 1664 kilojoule per mole. In the next module, let us discuss the concept of entropy. Please subscribe to my channel, like, share and comment on my videos. Thank you.